All right, today, the first day of a topic. It's titled Constructing Triangles. Last week, we ended the week with trying to figure out whether we could make a triangle based upon its sides, and we used the idea of the triangle inequality to help us make that determination. Today, we sort of continue with that idea by starting to incorporate angles, and that's why you have a ruler and a protractor today to help us with those ideas. So, today, number one, you and your shoulder partner sketch a triangle with the given information below. One side and one angle are given. So I want you right now, with your protractor and your ruler, I want you to try and create a triangle that has one length of 5 centimeters and an angle that is 120 degrees. One side of the triangle has to be 5 centimeters, and one of the angles has to be 120 degrees. And then once you've drawn your triangle, I want you to compare your triangle with your shoulder partners, and then we're going to answer some questions based upon that. So go ahead and give that a shot. So we're trying to create a triangle where one of the lengths is 5 centimeters. Put that down, please. And one angle is 120 degrees. So I'm going to show you that there's more than one way of creating a triangle. So watch. I'm going to start with my ruler here, and I'm going to draw a side length of 5 centimeters. That's my bottom, what we normally call a ray, but I'm restricting it here since I want it to be 5 centimeters long. And I bring in my protractor, and I want the angle to be 120 degrees. And then I connect them together to make a triangle. So there's one triangle that has a side length of 5 centimeters and an angle of 120. But this side right here, it does not have to be that long. It could be shorter than that if I wanted it to be. So watch. I'm now going to, right on top of that, I'm going to draw a shorter side right there. And then enclose it together. Now you can clearly see those two triangles are not the same triangle. They both have one side that is 5 centimeters, and they both have this angle right here that's 120 degrees, but they are different triangles. And that's what we're trying to keep track of today. Can I only create one triangle like that, or can I create more than one triangle like that? And in this one, yes, more than. Let me just show you another one. Here's an example of what you could do. We have many different ways of drawing a triangle like that. Okay? All right, so let's go down to number 2. Number 2, I want you to try and draw one triangle that has one angle of 90 degrees and another angle of 60 degrees. And we're going to kind of do the same thing. We'll compare that with our shoulder partner. One angle of 90 degrees and one angle of 60 degrees. All right, so we ended up with different ones, and that is what most of you said. But let me show you a little demo proving that there are many ways of drawing a triangle with two different angles. You were supposed to draw one with an angle of 90 and with one of 60. So here I have two different triangles with angles of 90, right here. That angle and that angle are 90, and that angle and that angle are 60. You can clearly see that it's easy to draw two different triangles, or more than that, that have two of the same angles in them. And that's why most of you got different sized triangles when you drew your two triangles. All right, let's go on now. Many triangles are possible there, and the reason is because we have similar figures, and we're going to come back to that idea in another day or two. All right, number 3. This time you're trying to create a triangle with one side length of 4 and another side length of 6. That's the only information I'm giving you. Create one triangle where one of the sides is 4 and the other side, or one of the other sides is 6. I'm not telling you anything about the third side. So this lesson and the two previous lessons, it's all about when can we create a triangle and when is it not possible, or now it's like, can we only make one, or can we make more than one? Well, here's one example of a triangle that might have 4 centimeters and 6 centimeters on a side, and here is clearly a different one. There's more than one way to create a triangle with 4 centimeters on one side and 6 on the other, and that's basically hints towards the triangle inequality that we talked about last week. All right, there is a pattern here, and at the bottom of your notes on this side, we have some spots where we need to fill in your notes here. 2 pieces of information are not enough to create only one unique triangle, and by unique, we mean only one of its kind. In all the first 3 problems, there was more than one way to create a triangle. That's why I had you show your shoulder partners and then compare with the people around you so that you could clearly see there was more than one way to create those triangles. And some of them didn't even look close to the same. So let's go a little bit further into this investigation. Let's go to the back side of your notes. Now, draw several triangles if you can, based on the description below, then make a conjecture about the different number of triangles that are possible. And by conjecture, and I'm sure you've talked about this in science before, but if you haven't, a conjecture is where you're making a conclusion based on patterns. So I want you to create more than one triangle if you can, where one side is 6 centimeters, another side is 6, and the third side is 4. And then we'll answer the question, how many different triangles can you make? I'll give you about a minute or 2 to try and come up with that. All right, so let's take a look at this. And one thing that I mentioned as I was walking around is just because you turn your paper sideways, that may not make it a different triangle. So let me go to another demo here. And switch this to 3 sides. And so if you were supposed to make one side 6, another side 6, and another side 4, and basically there is only one way of creating that triangle, and it would look something like this. Now some of yours may be drawn like this instead, but it's the same exact triangle. There's only one way that you can make that triangle. Some of you are struggling and really trying hard to make a second one, but you can't. And that's what we define as a unique triangle, because there's only one triangle that you can make with those side lengths. And that leads us to this right here. And on your lines, I would like you to add all 3 of these lines right here. That's what those lines are there for. Only one triangle is possible. This is defined as a unique triangle, and the SSS stands for side, side, side. If you are given 3 sides and you're trying to draw a triangle from that, you can only make one triangle. So once again, we can only draw one triangle because we were given 3 sides, and of course we checked with the triangle inequality to make sure we could draw one period, and we can. So now let's go to number 5. This time, 3 angles are given, not 3 sides. One angle needs to be 80 degrees, another one needs to be 40, and the third one needs to be 60 degrees. How many triangles can you make? So I'm going to come back to you in about 3 or 4 minutes and see what you have. So in number 4, we talked about the fact that the triangle inequality told us that we could at least draw one triangle, because 4 plus 6 was 10, and 10 is greater than 6. In this problem, the triangle sum theorem from last week states that we can make at least one. The question is, can we make more than one with those angles? And we can. Many triangles are possible. Let me just show you. And this is another example of similar figures. Here's one very small one with angles of 40, 60, and 80, and here's a bigger one. And I could draw as many as I wanted to. These are similar to each other. We talked about similar triangles earlier in the year, and we're going to come back to that later this week. So we can create more than one. And we're going to stop right there for today, and we'll continue this idea tomorrow.